You have previously watched a video that shows you how to find the x-intercepts of a standard form quadratic directly by using the quadratic formula, which is shown here on the screen, and it should be in your flipbook, bottom of section 3. Now class, what I'm going to do is I'm going to go through 3 practice problems, and the intention for you is to try each practice problem, see if you can go through the steps of using the quadratic formula to find the x-intercepts or the solutions, check your work, and if you've got the right answer, move on to the next one. If you didn't, then look at the steps, listen to me as I go through the steps, see if you can figure out where you are not understanding the process, and then try again for the second one, and then try again for the third one. The goal is by the time you get to the third practice problem, you will be very clear about how to use the quadratic formula to find x-intercepts or solutions. So, if you would, on your paper, for question number 1 or practice number 1, write this equation. Number 1, y equals x squared minus 12x plus 36. Okay, so before we even start using the quadratic formula, we have to make sure that all of our terms are on one side of the equal sign, and they already are, but we also know that y is going to be equal to 0 when we are looking for x-intercepts or solutions. So I'm going to go ahead and rewrite the equation. I like to have my function actually on the left side. You don't have to actually switch them around, but it just makes more sense to me to have the 0 on the right. So there we go. There is our equation, and now it's equal to 0. We can go ahead and solve using the quadratic formula. First thing we're going to do is find our a value, which is 1. Our b value is negative 12. And our c value is 36. Now again, something powerful about the quadratic formula is it doesn't have the restrictions that factoring or complete the square do. For factoring, you have to have a positive a value, and you want to pull out the greatest common factor to make it easier. For complete the square, you want to try to get the a value equal to 1, which makes it easier to complete the square. For quadratic formula, you can ignore all those steps and just use whatever the a, b, and c value are. You don't have to find a common factor. You don't have to get a positive or equal to 1. Which is nice. All right, step number 1 of quadratic formula. We're going to find the discriminant. The discriminant is found with the formula or the expression b minus 4 times a times c. And if you look at the quadratic formula, that is just the expression that's in the radical. We're going to do that separately. 1, because it makes the quadratic formula easier to use, and number 2, because the discriminant tells you something about how many x-intercepts or solutions you have. So let's go ahead and plug in our values. Our b value here is negative 12. We're going to use parentheses as we always do. Negative 12 squared minus 4. There is our a value in parentheses, and there is our c value in parentheses. Okay, so let's go ahead and use our calculator to actually find the discriminant once we've figured out all the values. So let's bring up our calculator. Let me move that off to the side if I can. And let's try this out. Alright, so we've got parenthesis, negative 12, close parenthesis. Whoops, let's get that to be 12. 12 squared minus 4. Put 1 in parentheses, put 36 in parentheses, and press equal. And we actually get 0. Our discriminant here is actually going to be equal to 0. Okay, let's now, next step is to actually find our x-intercepts. Take a look, we got step number 1, find the discriminant. Step number 2, find the x-intercept. So let's do step number 2. Let me change that color. So, the quadratic formula is negative b plus or minus the square root of, well, we already found our discriminant. We already know this value is 0. Divided by 2, man, I can't get that line to look very well, class, 2a. All right, so b is negative 12, but there's a negative or a subtraction, no, sorry, not a subtraction, there's a negative in the equation. I don't know why that 0 went away. So I've got to put the negative sign first, and then there's my b value, plus or minus the square root of 0 divided by 2 times 1, which is a. Let's go ahead and simplify this. Negative times a negative is a positive, so we've got 12 plus or minus the square root of 0 divided by 2 times 1, which is 2. There are our x-intercepts. The last step is write your final answers. So just to show you or verify what our final answers are, they're going to be x is either going to be equal to 12 plus the square root of 0 divided by 2, or 12 minus the square root of 0 divided by 2. Now we can simplify this, class, because 0, square root of 0, is actually 0. We know that's a perfect square. So we can actually simplify this final answer. Let's go ahead and do that. So we've got x is equal to, and to simplify this, let's put it in our calculator. Remember what I've said in the video. When you put it in your calculator, you have to put the numerator in parentheses. Otherwise, the calculator is not going to know when your numerator ends and when your denominator begins. So let's go ahead and put this in the calculator and see what we get. So I've got parenthesis 12 plus the square root of 0, and I'm going to close the parenthesis on my radical and then close the parenthesis on my numerator, and then I'll divide by 2. And our first value is 6. So our x values, our first x-intercept is actually 6. Let's do the other side of that, the 12 minus the square root of 0. So I've got parenthesis 12 minus the square root of 0, close parenthesis on the radical, close parenthesis on the numerator, divided by 2, and I end up with the exact same value. And that makes sense, class, if you look at it. Since the square root of 0 is just 0, this is going to be 12 over 2 and 12 over 2. So I don't need to write this comma. I can just close the parentheses. My x-intercepts are only 6. Okay, now one more thing. We learned this in the video. If you take a look at it, I told you the discriminant tells you things about the number of x-intercepts or zeros or solutions. Those are all the same thing. It says here, if the discriminant is 0, you're only going to have one real x-intercept, one real solution, one real 0. And we can also say one real root. So because of that, we know the discriminant told us that already. Let me clear these lines out of here real quick. So you could have written, even before you solve this one, you could have written, class, that since the discriminant, and write this down on your worksheet, since the discriminant was 0, then the number of x-intercepts was going to be 1. When the discriminant is 0, the number of x-intercepts is 1. Alright, that's the end of the first video. Start up on the next one. I'll give you a second problem to practice.